Assalamu alaikum viewers. Today our topic is lowest common multiple, most commonly known as LCM, or the abbreviation for lowest common multiple is LCM. Now lowest common multiple, as the name suggests, we have to write the multiples for the number. If we are given in a question numbers, we are first going to write their multiples, then we are going to write the common multiple, and in the end we are going to find out the lowest common multiple. That means we are going to go backward. And I hope that all of you know that what is the meaning of multiples. Multiples means that if we are given some number, we have to write that when that number is multiplied with 1, 2, 3, 4, what is the answer that we are going to get. For example, if I have to find the lowest common multiple of 6 and 9, so what is the first method I am going to use is the listing method. In listing method, what I am going to list down is, I am going to list down the multiples of 6 and 9 separately. When I say multiples, that means I am going to write the table of 6. 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, 6 fives are 30, and in this way we will keep on writing the multiples of 6. And then we are going to write the multiples of 9. 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, and we will keep on going like this, right? After writing the multiples, I have to find the common multiples. Common multiples means that the number which is our multiple which is coming in both the numbers, or the number, as many numbers as you are given in the question, you are going to find the common multiple. As you can see here, the common multiple in both the number is 18. So my common multiple will be 18, right? Since I have got only one common multiple, so my LCM, I have to find LCM is the lowest multiple. So the lowest multiple here is 18, so my LCM will be 18. This method of finding out the LCM is very difficult, because if you have forgotten any of the multiple to be written here, then you might not get a correct answer. So we can use this method. If you are good in tables, you can use, but it is time consuming and difficult. The second method of finding out the LCM is by prime factorization. As the name suggests, prime. Prime means that we are going to use the numbers which has only two factors, 1 and itself. And we are, for example, I am given two numbers. Suppose I will take 30 and 36. So if I am going to use the listing method, it will be very difficult for me to write the tables for 30 and 36. So what I am going to use is, I am going to use the prime factorization method. In the prime factorization method, I am going to make a like this. I am going to divide it, right? Now I have to find a factor. Factor means a number which is going to exactly divide this 30 and 36. 2 because it has 0 in the end and it has an even number in the end. So I am going to take 2 in the beginning. When 30 is divided by 2, you have to mentally divide this 30 with 2. So what you are going to do is you are going to take 3, and in your mind when you are going to divide 2 ones are 2, 2 twos are 4. We cannot write 4 under it. So what we are going to do is we are going to write 2 ones are 2. And when 3 minus 2, I am going to get 1 as the remainder. This 1 is going to come with this 0 and it will make 10. So 2 5s are 10. Same is the case here. When I am going to divide this 2, I have to simultaneously divide all the numbers with 2. When I am going to divide this number with 2, 3 divided by 2, it is going to go 1 once. So I will be having a remainder 1. 1 and 6 makes it 16. 2 8s are 16. Now you can see that I have got 15 and 18 using the rule of divisibility of 3. When I am going to add these two numbers, if they are divisible, the sum is divisible by 3. These two numbers are also divisible by 3. 1 plus 5 is 6. 6 comes in the table of 3. 1 plus 8 is 9. 9 also comes in the table of 3. So that means these two numbers are divisible by 3. 3 5s are 15, 3 6s are 18. Right? I can further divide it. For LCM, I should keep on dividing until and unless I get 1 in the end. But I can stop my division where the numbers are not coming in one table. Now here I have 5 and 6. I will take 2 and 5 and 2 3s are. Now I can keep on dividing it with 3, 5 and 1 is going to come and then 5 also. But you can do this also, that here the moment they have started coming in different tables, you can stop your division here and you can multiply all the factors which are here. Right? I mean to say that I can stop my division here. I can multiply all these factors together to get my LCM. But if you have done till the end, that's also fine. So my LCM in this case will be, I will multiply all the factors and it will be 2 multiplied by 3 multiplied by 2 multiplied by 3 multiplied by 5. I have heard from my students that we cannot write a bigger number and after the bigger number we cannot write the small number. It is not a hard and fast rule that we cannot use a big number in the beginning. We can write a big number, but the factors should be prime. Now 2 3s are 6, 6 2s are 12, 12 3s are 36, 36 multiplied by 5 is 180. So my LCM is 180. Right? So 36 multiplied by this is 180. My LCM is 180. See, this method is called the prime factorization because I have used all the prime factors and I have multiplied. For the LCM, I have to use all of them. If you remember, I have told you that the resemblance, or if I'm going to compare the HCF and LCM. The thing which is different in LCM and HCF is that in HCF, the moment the numbers start coming in different table, we stop our division and we take only the common factors for HCF. But for LCM, we have to take all the factors which are common or which are not common. We have to keep on dividing so that we can divide all the numbers and in the end we get 1. Right? So this is the difference between HCF and LCM. For LCM, we are going to take all the factors. This method is called prime factorization. The other method, which is also similar to HCF, is index notation. Now the LCM for 30 and 36, 30 and 36 I have got is equal to 180. I'm going to prove this, or I am going to prove this LCM with the help of index notation. Now for index notation, what I have to do is I have to divide the numbers which are given to me separately. 30, I am going to find the factors for 30. 2 15s are, 3 5s are, and 5 1s are. For 36, the factors will be 2 18s are, 2 9s are, 3 3s are, 3 1s are. Right? So the factors for 30 are 2 multiplied by 3 multiplied by 5, and the factors for 36 are 2 multiplied by 2 multiplied by 3 multiplied by 3. Now index means that the index means power. When we are doing question in the form of index notation, I should write my numbers in the form of power. And when I am going to write it in the form of power, as you can see here, these numbers are called base. If I have a number which is written as 2 raised to the power 5, so this is called the base, this is called the power, and the other name for power is index. The plural for index is indices. So when I say I have to show these numbers in the form of index notation, that means I have to write it in the form of power. But for writing the numbers in the form of power, the base should be same. As you can see in 30, all the bases are different. So what is the power in all of them? Power is 1. So 1 is usually not written, and I am not going to do any change in this thing, and it will remain as it is. Whereas for 36, I can write it in the form of, since 2 is the base and it is coming 2 times, so the power will be this. The rule of indices says whenever we are multiplying same base, our power should be added. Multiply by 3 is multiplied 2 times, so my power will be 3 square. Right? So when I have written this in the form of index notation, 30 is written as 2 multiplied by 3 multiplied by 5, and 36 is written as 2 square multiplied by 3 square. Now what I have to do is I have to write my LCM. So for LCM, as we have done previously, we have taken all the numbers. Either they are common or they are not common, but we have to take them all. So that's why in LCM we take comparing the same base, we are going to take the highest part. Here the base is same, and this 2 has power 1 and this has power square. So I am going to take 2 square. Comparing this 3, I am going to take 3 square. Now since for LCM we are taking all the numbers, even if they are not common in both the numbers, we have to take it. So same is the case with 5. I am going to take this 5 also. Now 2 square means that this number is multiplied 2 times. 2 times multiplied, so 2 2s are 4. This means 2 multiplied by 2. This means 3 multiplied by 3 multiplied by 5. 2 2s are 4. 4 3s are 12. 12 3s are 36. 36 multiplied by 5 is 80. So my LCM once again is 180. We can use any method, prime factorization or index notation. We are going to get the same answer. I hope that this is clear to you. But if I am going to compare this with the help of HCF, for HCF, when we are going to compare the indices, we always take the smallest power. And when comparing the same base, we are going to take the smallest power, and the thing which is not common in both of them, we are not going to take it. Whereas for LCM, we are going to take all the things those are which are common, which are not common, and we have to take the highest power. Hope that this video is going to make the concept of LCM clear to you. Thank you.